today we'll be discussing the topic that is the minimum spanning tree, and we'll be discussing an algorithm that is the Kruskal's algorithm. So what do you mean by a spanning tree? A spanning tree is a subset of a graph G that has different vertices which are covered in a minimum possible number of edges. So we can say that a minimum spanning tree does not have any cycle or a loop, and it cannot be a disconnected graph. So for example, we have here a particular graph consisting of three vertices. The different spanning trees for this particular graph has been shown like these with different number of edges and vertices. We have found three spanning trees for this one particular complete graph. Let us discuss what do you mean by a complete undirected graph. We can say a complete graph can have a maximum of n raised to power n minus 2 number of spanning trees, where n is the number of nodes. If we are considering this example where n is equal to 3, that is the number of vertices, so n raised to power n minus 2 would be 3 raised to power 3 minus 2, that would be n raised to power 1, that represents 3 spanning trees for a particular graph. Now, what are the different properties of a spanning tree? These are the different properties of a spanning tree which are connected to a particular graph. We can say a connected graph can have more than one spanning tree that we have shown in the figure. Different spanning trees for the graph can have same number of edges and vertices. The different spanning trees does not have any cycle or a loop. If we remove a particular edge for a spanning tree, that will make the graph disconnected. So we can say that a particular minimum spanning tree is a minimally connected graph. If we add a particular edge to a spanning tree, that will create a circuit or a loop that we have to avoid so that a spanning tree can become a maximally acyclic graph. So the definition for a minimum spanning tree is that in a particularly weighted graph, we have a spanning tree that has a minimum weight than all other spanning trees of a same graph. Let us discuss the algorithm, Kruskal's algorithm. Kruskal's algorithm is used to find out what is the minimum spanning tree for a connected weighted graph. The main target for an algorithm is to find out the different subset of edges by which we can traverse each vertex of the graph exactly once and calculating the weight for those vertices having the minimum possible weight in order to obtain a minimum spanning tree. The steps for an algorithm is that in the step 1, you have to create a forest such that each graph would be treated as a separate tree. Next, we have to make a priority queue that contains all the edges of the graph along with the weight. We have to repeat the step 4 and 5 until our priority queue does not get empty. Then we have to remove one edge from queue, and then we have to add that particular edge into different values. If the edge obtained in a particular step connects two different trees, then we can add it to the forest. If they are connected to the same tree, then we'll discard that particular edge, and in the last we'll end with the particular algorithm. Now, the algorithm for this Kruskal consists of two parameters, that is the graph and a weight value W, where A is an array, that is an empty array. For each vertex that belongs to the set of vertices, we have to make a set of V. That means each vertex will be treated as a different set. We have to sort all the edges in a non-decreasing order by weight, and we have to check for each edge UV that has been taken in a non-decreasing order by weight. We have to find out their set. That means we have to find out the parent set. If the parent set of U or a find set of U is not equal to the find set of V, then we can add that particular edge, and then we'll start combining the different edges and we'll make a graph. If the values are same, then that particular edge will not be added. Or we can say if adding a particular edge into the graph can make a circuit or a loop, then that particular edge would be avoided. The examples of Kruskal's algorithm, first of all, we have to remove all the loops and the parallel edges from the given graph. Here we can say we have a loop edge that is from C with a value 1, and we have a parallel edge from A to B with a value 9. One point that is to be remembered that we have to remove that particular parallel edge from the given graph which has a minimum weight. So the edges after removal, the graph would be, so we have removed a parallel edge from C and we have removed a value A to B that has a value 9 from the graph. Now step 2 is we have to arrange all the edges in their increasing order of weight. So according to the figure, BD has a weight 2, DT has a weight 2, AC has a weight 3, CD has a weight 3, CBH has a weight 4, BTH has a weight 5, ABH has a weight 6, SA has 7 and SC has 8. Now we'll start making the minimum spanning tree. We'll start with the first node or first edge from the queue. We'll remove that particular edge from the queue and make it in a graph. So we have used the edge BD with a value 2, DT with a value 2. Now moving on to AC. Adding AC does not make a loop, so we'll add AC into this. Now moving on to the next edge, that is CD. CD is value 3. This will not add a loop or a cycle, so this particular edge will be added. Now next is we have a value CB, that is 4. So CB will make a loop, so we'll avoid that particular edge. Now BT will also make a loop, so we'll avoid that particular edge. AB is a value 6, it will not make any difference. Then we'll add this. We shall ignore those particular edges or vertices which make a loop. The final graph that would be obtained after adding all the nodes that are with a value less than the different values that have been given in a non-decreasing order by weight. So we can calculate the particular minimum spanning tree weight by adding all these weights from all these edges. So 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 2 is 15, and 15 plus 2 is 17. That is the total weight. So by adding SA, we have included all the nodes of the graph. We can have minimum cost spanning tree. Or we can say if we have n number of nodes, then there would be n minus 1 edges. So if we have 6 nodes, then we have 5 edges. So let us see SA is 1 edge, AC is the second edge, CD is the third edge, DB is the fourth edge, and DT is the fifth edge. And we have total number of 6 vertices. The total running time, or we can say the complexity of a Kruskal's algorithm is order of E log E, or we can say E log V, where log terms have been computed on the basis of the priority queue. There are different algorithms other than Kruskal, which can be used for calculating the minimum spanning tree weight as a Prim's algorithm. Thank you.